position.
You're not supposed to be.
Alright.
All right, welcome. I'm Warren Scott. I'm work at Tektronix. I'm going to be talking to you about using Teststand as a full-fledged test executive, basically trying to pull off and do some traceable calibration against ISO 17025 or Z540 or kind of any of those other standards that kind of define a metrology program for using it for more than testing a computer motherboard or whatever the standard examples are that come around. The full disclosure of this is, yes, we are at a LabVIEW developer days type of thing, but there's a last minute cancellation of the presentation, and they called me up and said, hey, how about you do a presentation? I said I could do something on Teststand. That's not LabVIEW, and they said, we don't care, sounds good enough, go for it. So that's where that kind of comes through. A little bit of legal disclaimers. This is how we did it. Examples are, for example, purposes. Don't take anything fully in absolutes. It's the best of my knowledge, a bunch of this is a little bit outdated of a version of Teststand or two ago, but I will add on or ask questions as we go through. Like I said, I work for Tektronix. We supply test equipment to hopefully a bunch of you, and thank you for helping to pay my salary. Keithley is part of our umbrella of corporations, so we've got all the Keithley DMMs and Tektronix oscilloscopes and spectrum analyzers and function generators and all that kind of stuff. And if you know more parts of stuff and are enjoy the Seattle area, we are a sister company under the Fortive umbrella with Fluke, known for their yellow DMMs. How we use NI software at Tektronix, we have an internal test executive based off of National Instruments Teststand and LabVIEW. We term it as TechCal NI. It's based off of Teststand, that we have a very heavily customized process model that provides a consistent UI across all of our products for testing, and common report generation, database logging, all that is the same every factory, every station around the world that we do. And LabVIEW does all the test modules behind that. We started using LabVIEW Teststand somewhere around the 2002 timeframe, and it has basically taken over our design validation, manufacturing qualification, manufacturing test, and service repair test calibration. Little bits of the picture of where we are. We've got test systems popping off to instruments. We have a separate code deployment process that is homegrown. This is kind of what System Link kind of does now that they're talking about. We have a whole bunch of manufacturing infrastructure, connectivity into quality systems and Oracle order management type of stuff, and then off to a database for managing data results, certificate printing, analysis, other fun stuff like that. So what this comes back down to is Teststand out of the box does a really good job at testing consumer products that are just a ship it or don't ship it. Something like a computer motherboard is a standard example if you've gone through any of the Teststand out of the box examples. Great at doing something like that. But we're in a slightly different realm of we don't ship computer motherboards, we ship traceable calibrated items that if we said 1 volt and it wasn't quite 1 volt, we wouldn't be in business very long. And basically the idea behind either the ISO 17025 or ANSI and Z540 is putting together a metrology program that kind of guarantees that when I say this is 1 volt, I have a traceable path of all those measurements and all that data I have back to whatever you want to define as the country or world standard of 1 volt or 1 second for that. And whether you believe us or we go off and get it accredited by another laboratory that says, yes, we're doing it right, is where we get it accredited. and we're shipping off a certificate of compliance or traceable calibration to you that provides all those measurements to you and tries to convince you that we're doing it right with kind of a data report. So that's all real different than just getting a green screen at the end that says motherboard passed. And that type of stuff Teststand doesn't do well. All the features aren't quite there out of the box. NI's been getting better, so some of this is improved, but not all the way there with the newer versions. But this also relies on other parts that weren't necessarily provided by the NI infrastructure of, do we have a good data results archiving system and a good analysis system, and all that is kind of getting towards diadem and system link and kind of getting towards a SQL database behind the scenes and other stuff, but not quite. Oh, I've got stuff in front of my pictures or behind my pictures. Closer look at a certificate of what we end up shipping off to you guys from there. This is an actual certificate. I've got red and green kind of color-coded into that of any of the green stuff is what out of the box Teststand will has a good answer to of the information that needs to. The stuff in the red, not so good, at least out of the box. So I've got a model and a serial number and a date and a procedure used. Teststand knows the instrument I tested. It knows when I started testing it, when I finished testing it, and all the sequence files have a revision, a sequence file version number that can be claimed as a procedure that was used. Teststand does not have a manufacturer of a product. There's just a UUT that's kind of generally a model underscore serial number smashed together. It doesn't have an idea of a description of what it is. We can extend our UUT definition to do that. It doesn't have an idea of temperature and humidity or other environmental conditions that things are tested by. We can expand for that. We'll talk about that a bit. Receive return condition. If we're doing something for service, we have to know the customer shipped it into us, we tested it, it wasn't looking so good, we made some repairs, we gave it back to you, this is how we changed it. Equipment used to know the full traceability path of every DMM, every signal generator, every cable, every adapter that's in the traceable calibration path. What are all of those? And additional managers of Teststand has one user that it logs in as the beginning, but if you're in a calibration lab, sometimes you have to have a whole chain of all the management chain and authorizers for that event. And other things like firmware versions are starting to become a lot more important in the newer standards. You should be recognizing that. Looking further on, that's kind of the first page, then you get down to the second and third page of documents and you actually start looking at the actual data results that are gathered. And Teststand has a good idea of like, okay, I measured something, I have a test name, step name, and I have some limits, and I have a measured value and a set of units, and hey, and whether it passed or failed. That's great, but, excuse me, when you really get into the metrology side of stuff, you have a nominal value for that measurement, and you have an uncertainty around that measurement, and things don't just pass or fail, they have indeterminate states of gray areas of what happened. All that stuff works, nominal value and uncertainty, indeterminate results. Also, you end up with dealing with internal limits and external limits, that if you're actually guard banding or putting some amount of process control around your manufacturing process, you need to test to one set of limits, but advertise to the customer on the data report so you have a different set of limits. Teststand doesn't deal with that stuff very well out of it. Also understanding whether I'm over-testing and doing it, and I am testing 100 different data points, but only reporting 10 of them to the customer because that's what's warranted. That type of information doesn't come out of the box for free. Handful of these aren't there, and some of the nominal values and uncertainties, some of the newer versions of Teststand have some good attempts at solving the problem. Let's put it that way.
Not like Metcal.
Metcal has a whole other set of problems.
Yeah.
Metcal deals with some of these really well, and we're just going to take these and throw them up in the air and swizzle what works well and what doesn't work well, and happy hour after a beer. Or two. So for manufacturer, so talking a little bit about what we had to do to extend some of these data parts of Teststand to be able to accommodate some of this. One of the beautiful parts of Teststand is it's very extensible of all of these data structures, almost all of them at least, are available for you as the user or the developer to modify and change and add to as you see fit and as is needed for your process. That also means you can modify them and you can make a world of hurt for yourself, and you can have 10 different versions floating around your company because you've modified it to 10 different ones, and how to standardize on that and control it takes some effort. And standardize where you can. Basically, we had, instead of modifying the out-of-the-box model definition, we just decided to add in an additional model definition that had what we needed to. So we weren't necessarily modifying what's out of the box, we were adding on to it. That way, as versions of Teststand get released, it's a little easier for us to adopt the newer versions and understand where our changes are carrying through versus what NI is bringing on as standard. So we end up with a manufacturer model description, and we end up with some logical name information there as well for communication handles to talk to it. Serial number gets left out separately. So we end up with a customized UUT selection dialog that looks very much something like this. And this gets into the substantially larger definition that we ended up putting in place for the model. Temperature, humidity, or environmental conditions in general, we'll simplify it down to temperature, humidity, is something we end up having to gather for each of the calibrations. In general, we found the easiest way is put a callback in place into our customized process model that will go off and talk to a environmental conditions monitoring database that we have that talks to a set of environmental monitoring temperature humidity sensors around the plant every couple minutes, and stores that data in the database, and we can go off and say, hey, this station is closest to this sensor, go off to the database at the start of the test, gather the data, measure it, or set up for manual mode where the operator gets to hand type in the temperature humidity based off of whatever probe they have sitting close to their desk at that time, what they're doing. But then that can we can add into our result structure additional information about the sequence header that we have an environmental temperature, humidity, pressure, dew point, whatever we want as part of that. And you can put in kind of different validation checks in there for what is an appropriate range for performing these tests. That maybe 50 degrees C is okay, because we're doing environmental type testing. Maybe 50 degrees C is out of normal bounds, and we should shut down the system and not do any testing.
Do you pull that from a database, or is that something user selectable? Which
it's kind of configured by the engineer running the system, because we'll take one system and one set of test parameters and run it on the production floor or the service facility and expect a nominally this environmental conditions. But then we'll take that same test procedure and with slightly modified limits and expect to run it on an instrument that's in a temperature chamber. And so that test system that's hooked up to the temperature chamber, we get in and say, hey, push it to 50 degrees C is acceptable now, as opposed to expecting 23, 24. Okay. So. Received return condition, or as found, as left, incoming, outgoing, whatever your favorite service jargon is. Basically comes down to the manufacturing process for motherboards and things like that is real easy. You build it, you test it, it passes because we never have failures. You ship it and customer gives you money for it and everyone's happy and it never comes back. But realistically, you deal with expensive products, and for service it comes in, you have to test it. It might pass, it might fail. Generally, if it's coming back to you, there's a decent chance there's a reason the customer's sending it back to you for calibration, that they don't think it's quite working right. Maybe we readjust it or do some repairs, we test it again, maybe we loop on this adjustment and repairs a couple times until we figure out what's really wrong with the product. And then finally we end up shipping it and getting some money for the calibration or repair one way or another. And the end result of shipping it back, we may end up getting and talking to the customer and saying, hey, you know what, it's gonna cost you a gazillion dollars to repair this because of how old it is and where the parts are availability and all that. Do you really want us to spend a gazillion dollars repairing it for you? And they say, no, we accept these failures, please ship it back to us in that condition and just properly note it on our data report. So we can ship back with failing results, and that's okay based off the customer. We have to let them know what the data was when it first showed up at our plant and as it left, and any adjustments we perform. So all of a sudden we've got multiple sets of data, and we have to end up then putting a prompt up when we're in doing service facilities that is this the before or after incoming outgoing data. But again, that's just a hook into our custom process model, put up the prompt, ask the operator what's going on, and store the results of that into the test data results. And there's all kinds of other fun stuff you can do into there of knowing that, hey, the user selected outgoing, but there's no recorded incoming data for that, and put up weird little warning boxes for the operator saying, I don't know that you selected what you really thought you were trying to select, and other pokey-yoki type things around that. Equipment used. So we saw back on the certificate a bunch of pages ago, we had the list of all the different equipment that we used during the calibration. All the DMMs and cables and adapters and all that fun stuff. Excuse me. We manage that. All that gets officially managed through an asset management system, a calibration management system that keeps track of all the cal dates and due dates and where everything's deployed. From the NI side of stuff, System Link is kind of moving towards that way of being able to do some of that. Almost stay tuned to your local NI sales rep for more information later, if we had local sales reps anymore. Did I say that out loud?
Oh, there actually is.
Can I call you on the phone and have you show up in my office the next day and talk to me about something?
Me, probably not.
Anybody?
Depends.
Yeah.
You guys are taking a beating today.
He's not denying it. So that's one side. We store all that information in a custom structure in our station globals files on that station that says, here's the list of equipment that's on this system, and it gets updated periodically against our asset management system. And does a bunch of checks to say, hey, yeah, let's make sure the cal dates are appropriate for what we're doing. And then we work through a custom handle management structure that we've put in place to say go through our get handle process that works through the logical names in the equipment list, that once I say get a handle to DM1, it automatically goes into the station globals equipment list, finds out what DM1 is, puts that in the list of, we opened a handle to this, so let's put it in the list of equipment used so that it goes on the certificate. So that removes a lot of onus from the test engineers of having to know exactly what instruments are being used, except for the ones like little adapters and cables that you don't actually talk to, that aren't communicated with, that you have to manually say, yeah, I added adapter 3, so put that on the equipment use list as well. All right, so we're going to get into a little bit of the anatomy of the measurement and where Teststand fell short greatly a couple versions ago, and where things are getting a little bit better. but we're not quite there yet, and where we have to start adding a bunch of fun stuff onto it. These little round dots here are all the measured values, and I can make a measurement here, and I can have an uncertainty around it. And that means I could be, even though I measure this, it could be anywhere within this based off of my coverage factor and all kinds of other metrology gobbledygook. And my actual measurement here may be passing, but based off of the uncertainty bounds, there is a probability that even though I measured a passing value, it could actually be a failing instrument, despite any amount of guard banding I might do of my internal test limits versus the external customer test limits. So there's a whole round of, if I'm in here and the value I measured passes and the worst case of my uncertainty within my coverage factor still passes, I'm confident that I can tell you as a customer, this instrument passes with my 99.9% coverage confidence factor, or whatever my K value is. For this one here, I can tell you it failed and there's no chance it would have passed, that the uncertainty of the measurement would have caused it to be a passing value. So I'm confident on that failure. However, these guys here, it passed, but there's a chance within my uncertainty that it could have failed, which means it's a passing value, but it's indeterminate. That I could be wrong based off the uncertainty. And the same way for a failure. It failed, but there's a chance I could be wrong. I have to call it an indeterminate result. Teststand has no idea about any of that. It passed, it failed, it errored, it skipped, it done. It's done. So we have to add that into it, or go really crazy into your metrology standards to the point where you as a measured value are not, you only measure values and report values and do not make any determination of pass or fail to the end customer. That's their responsibility to do it, but nobody really wants to listen to that unless you're a metrology lab, and those are not our customers in general. So because these real measurements are complicated, we end up having to extend our results structure to have our normal set of limits, an advertised set of limits, a nominal value, and a whole set of uncertainty around that measurement, which hopefully is generally static, or you can claim a worst case value and save that as a static value as opposed to dynamically calculating your uncertainty, and deal with some amount of indeterminate values. And for simplicity's sake, we just ended up having a Boolean of, yeah, we're in the indeterminate zone that gets added on to the general pass-fail status. Because overloading the existing pass-fail status with the Teststand was going to cause too much other problems. But the other parts of measured value units and standard sets of limits were doing reasonably well. So because we're running a custom process model, you can put some stuff into your process model post-step callbacks that goes back and looks at the measured value and all your sets of limits and your uncertainties and makes some determination of whether I'm in this indeterminate zone based off of limits and uncertainties and all that fun stuff. Questions on that? And this is the left to the exercise of the user, and of course it's simple to figure out if you remember that from college days and professors. Reporting side of stuff. With Teststand 2010 or so, things got a lot easier with the results processor plugins. Everything that we gather gets logged into a centralized results database. You do end up running local reports, HTML reports for troubleshooting and some code analysis, similar to Teststand sequence analyzer type of stuff. We also do get reports out of a centralized database that provides us ability to do troubleshooting and customer documentation, and fun statistical analysis out of any of the data results from there. Lab view side of stuff. So that's kind of the big picture of where we had to make a bunch of customizations to be able to get Teststand to be shoehorned into our environment that we have to play in. There's a couple things we ended up doing with LabVIEW that kind of said, this is a good overall best practices that we found and are pushing as kind of a LabVIEW architecture, internally at least, for how we plug into Teststand. What this means is we're writing code modules that plug in well to Teststand, or to some extent, more specifically, our customization that we've put on top of Teststand, which means our LabVIEW modules aren't necessarily portable to other people's architectures for test sequencers, test executives, but we're okay with that because they have to fit into our architecture. It also means that our LabVIEW code is lots and lots of small little, go measure the voltage of this, go measure the noise of this, go measure the bandwidth of this. And everything comes back to Teststand as our overall architecture and our executive and our UI, which means a lot of these big picture LabVIEW 00 stuff we've been seeing here earlier today, we don't care and doesn't matter to us. We write small little LabVIEW modules that plug into Teststand, which is our big behemoth. So yeah, from that, with our LabVIEW code ends up living by the sequence context wire of having a hook back into Teststand of what's the context that this LabVIEW code module is running under, so I know kind of where it lives in the whole process. We're going to go through a little bit about what's worked out well for laying our code on disk. Because of some of this, we don't do LabVIEW projects and stuff. It's all disk layout of files on disk, for better or for worse. How we all connect into Teststand and a little bit along those lines. So from that, we end up having what we end up as a common and configuration information, which is the common core shared reuse libraries that everybody uses that puts it into our framework and our architecture, and configuration side of stuff that our LabVIEW data directory, our Teststand config directory, all the configuration file localization stuff. We also end up having a standardized place where we're going to put all the drivers on disk. Instead of having to go to each station and install individual drivers, they get deployed by our code deployment process, where we end up having a drivers folder that has a bunch of categories of instruments, and all the DMMs are organized under there. So hopefully people get good reuse of at least the drivers modules. And yes, we do have multiple different flavors of drivers depending on whether people are running IVI or just a straight LabVIEW driver, or the DLL for CVI code or something else. Code layout stuff. Within that, similarly to how we had drivers, within our calibration code, we have sets of templates and then product categories of the different types of products we manufacture, or at least write calibration code for. So we have a folder that is all the calibration code for this type of spectrum analyzer with all the different test modules, test and sequences to go with it, and any set of sub-VIs or other parts that would go with those individual modules. So it's very much laid out on disk the way it would be. A lot of that carries over from many, many versions ago. Teststand could not understand projects at all. And our architecture worked well before that, and we weren't forced into changing, and it's working well enough. LabVIEW VIs from there. This is pretty much the standard connector pane for setting up any measurements or what we would have for a LabVIEW code module. We have a sequence context wire coming in and out for connectivity back into the Teststand of what's my handle back into Teststand for getting any information in or out, error in and out, and then measurement value of the step result in there. And notice that a lot of this is named very similarly to what the variable names in Teststand would be, so it's easy to understand, hey, where is this supposed to hook up to from the Teststand side? very specific to this test module or method itself, we have scope settings in DMM, logical name of configurations for the instruments of what their specific parameters, ranges, and configuration should be, or how to talk to it. From that front panel, that should look like what you would expect the connector pane, based off the connector pane. We do have constants and or more debug information over on this side to organize it somewhat. Internally, things got swizzled around a little bit. We've put in a pretty much the majority of our tests start off with an environment VI that goes back to Teststand and understands what's the environment that we're running in under here, and handles a lot of it for what is the UUT, how are you talking to the UUT, whether you're in a simulation mode or not, that we can swizzle some station globals on the station and put it into simulate mode where we can fake talking to the instruments and test the general sequence execution process without actually having to communicate to any of the hardware. A set of test methods and funky units converter through here. Because unfortunately, we want to reuse code modules as much as we can, which means we're going to measure an impedance, and it's going to come back in ohms from the DMM or whatever instrument we're using. But then when we report it in Teststand, it might be in ohms, or it might be in megohms, or it might be in some other scaled version of that. And it really sucks that Teststand can't figure out how to do any of that scaling for you in Teststand. So we do all of that internally. And understanding that from the sequence context, I can go back in here, talk to Teststand and say, hey, Teststand, I'm giving you this measurement. Teststand knows that the units of this step that I'm executing under are megohms, so I'm going to scale this by 10 to the 6.
I have a good question.
Yeah.
Are we talking to the Teststand in parallel, or it is a sequence wise? So Teststand is calling this particular VI.
Yes, so this is one of my test modules.
Okay, so we are talking in parallel with the Teststand. So
This is the method. This is the module for one of the steps in Teststand.
okay, so Teststand call this particular step.
There's
It'll
a step in
execute it,
Teststand.
is execute and then give the data to Teststand.
Yes.
So it's a sequential.
Yes.
Okay, no, it's not in parallel.
Right. Teststand has the ability to do parallel testing,
Okay.
so I can launch multiple instances of this in parallel.
Okay,
Uh,
can do. Okay.
so help you God.
Mm,
Trying to get parallel testing working well is hard.
okay. Okay.
But Teststand, it's got its own language. You can have it script and talk to the instruments itself,
Okay.
but it can also, for a step, call a VI,
Uh-huh.
call a .NET program snippet or whatever, you know.
So that is a recommended one. Okay, so
It-
I wanted to ask one question when we complete everything. So I'll
no, go ahead.
I can ask. So, can you write any program without help of any other things, any text sequence in Teststand itself? Can you do without help of any lab or so, LabVIEW or
It's
any other program?
really hard.
No.
There's
No.
Teststand only do calling module.
Okay, so only,
Automatic
it is
stuff.
recommended for only for module. Okay.
Well, but you can use Teststand with other programming languages.
Yeah,
You can
just
write
call
.NET,
it
you can
out.
write
That's the
C,
question. So yeah, all the
Sharp.
test we have to write in other language. That can be
Yes,
LabVIEW, C, or
all those
okay.
things can be called from within
Okay,
Teststand.
so- Okay.
And you can write drivers in those things if you really want to control, NI equipment, but
Okay, no, if you are writing any code in C++ or LabVIEW, I can do everything in LabVIEW, so why I need Teststand? So,
because
So, yeah.
Teststand is
Okay.
your sequencer and your test
okay,
executive.
Okay, okay.
So if you need to write a bunch of test modules, and then you have to then take all that data and generate reports and
So
log it
though
to a
reporting, yeah,
database
those things are
and sequence
standardized.
it differently,
Standardized, yeah, okay, for that one. Yeah.
that's where
Okay.
Teststand comes in.
Okay, yeah, well,
Or you have to write a crazy LabVIEW UI that handles that
Yeah.
sequencing and reporting
Yeah,
and
that's-
logging and all that.
Which
stuff.
is hard, because Teststand lets you loop and have variables going on and do a lot of things that if you make your own sequencer, you gotta recreate somehow.
It's already available, why not you use, and also it is.
And you can call
standardized.
subroutines and define your parameters to pass, so you can reuse a lot of sequences.
Okay, and I wanted to ask this question in, so okay, since it's already interrupted, I'll ask you. So, if you build application in Teststand, so can I build exe in Teststand for a
You can
Teststand?
build an executable, but it's really not gonna be an executable the way you think it is.
So yeah, that's, we can open and read the sequence, so it'll install in the program directory, then, but I'm able to edit the sequence, so that's not exe, I'll say.
No, so you have to take all of your test modules and get those packaged in one way or another. And then you have to take your Teststand sequence file and save that. And then you're still gonna be running a Teststand engine that opens the Teststand sequence file that then calls all of your code modules in LabVIEW or whatever else.
So I try to do build one exe, so we have a deployment, something there in Teststand, deploy, I build the engine, okay, workspace, I build it. And then once I install it, okay, it'll import all the files, so whatever test sequence LabVIEW, it'll build it, but no, whatever LabVIEW is there and whatever sequence is there, I'm able to edit it, so that's not exe, I'll say.
No, yes and no. So as part of the build process, you can define it and say, for all of my code modules, and we're gonna call all of your code modules LabVIEW code modules for now.
Okay,
You can block diagram remove all your code modules as you deploy, put them into the Teststand deployment.
okay.
Which means you can run your LabVIEW code,
Okay.
but no one can edit it because the source is gone.
Okay, what about the sequence?
The sequence file, you can protect it similarly. That you can put it into a mode where Teststand will not show any of the steps or allow editing. It can only allow execution of the sequence file.
Okay, so there is option there, okay, so, yeah, okay.
So like operator mode, and I forget what
Well, you can lock.
the modes are.
Yeah, you can lock.
So
Right,
once
so
you
it
install it,
depends.
then there is
So-
option like open by operator mode, open by test and run engine, or by a test and editors. If I link with open mode, then okay, he's not able
There's
to.
both ways. You
deploy.
can have a custom user interface that very much restricts what the operator can do. So all they have is just a start test button and
Yeah,
exit.
okay,
And they don't see anything, they just see the busy wheel going on testing, yay, you passed.
so but now, if I install something in C drive, somebody has got access to the C drive, they'll go to program, and then okay, they are able to see and make changes, the ex sequence file, so.
There are ways to help protect against that.
Well, if you're on a deployment machine, like the actual machine that's
Yeah.
running the sequence,
Yeah,
you can actually have the runtime can show you the sequence that's being run, but you can't edit it. With a base deployment license, you cannot edit a sequence.
okay, so that's the license issue, okay.
So, right, every machine that runs sequences has to have a base deployment license at minimum,
Okay,
and that's what will allow you to run, but it will not allow you to edit.
okay, so, yeah,
So
okay.
other license steps above that will allow editing.
Okay, so that's, so if I install some higher level of Teststand I have installed, maybe I have to remove, then okay, I have to put a base there.
Well, the Teststand itself can stay on the computer, or you can create a Teststand deployment image. But
Okay,
it's how
so-
you license that
okay.
particular computer that lets you
Okay,
edit
so
or not edit.
Maybe
sequence
that
files.
computer has got higher level license, that's why I'm able to edit it. So you're
Yeah.
saying, okay, so that's, okay.
Or you can set up the user as admin or operator only, stuff like that, so those operator cannot edit your sequence at all.
That's easy, yeah. Do it. And there's
For
password
Teststand,
protection as
okay,
well.
somebody for NI, they can, so, okay, am I disturbing? It's just final question then,
Okay.
I'll be done. For NI, like for Teststand licensing, so how it works? So, for every test station, we have to buy a license for it, or
For the deployment, yeah.
for deployment also? For lab is no, for build model, I'll just take one license and build any application that's licensed to me.
Correct.
But
So
Teststands,
LabVIEW,
we have any base model or something.
correct, yeah. LabVIEW, you can create infinite executables at no cost.
Okay.
Teststand does have a cost
Okay,
for the
one
deployment.
license. So which license I should be having? So
So the deployment is like the lowest level just to be able to
Okay,
deploy it
lowest
and
one,
run it.
okay.
And then there's like a debug which lets you do some modification
Okay.
editing, and then
So-
there's a full development license above
okay,
and beyond
that's fine.
that.
That's fine. Thank you very
Yep.
much. Thank you very much.
And the deployment's like $500.
Something like that. Per year.
Per-
year.
No.
No, one time.
One time. Okay.
But per
So
test.
Per machine, yeah.
Okay.
All right, so delving into it a little bit deeper, we already talked a little bit about this environment VI that gets information about very common things a user would want when they're starting a test module, what the UUT is, whether I'm in a simulate mode, doing some amount of error handling. Within a simulate mode, I can either just run my actual test of talk to the instruments and make some measurements, or I'll just do a random number generator, pass back a random result, and hope for the best that I can test all my flow control and data reporting, results gathering, all that kind of stuff. Unit scaling, we talked about that a little bit there, and where this really comes into is Teststand the Teststand sequence file user interface is my top level VI. That is what's running it. I don't have a parent LabVIEW project application that's running for that. All of my setup and cleanup and initialization stuff that you would have to do for a full-on LabVIEW test executive is all handled by Teststand, that it controls setup stuff, cleanup stuff, through all that. It really drives into the ability of how do I write my test modules to be reusable within this test process or another test process, whether I'm in a manufacturing environment or a design validation environment, which may be a slightly different set of tests or process that we're doing. And can I reuse some of that from an early on design validation side and not have to rewrite new methods when I actually go into production test for the product. It does mean that I am restricted into what Teststand expects for data results, that I can't go off and arbitrarily come up with my own parameters of what's getting passed back as far as data results. I'm kind of stuck with Teststand's idea of I'm getting back a numeric value or a string value or what the error structures are. I can't totally redefine the idea of an error cluster and expect Teststand to still work. So some limitations there of where I can expand the architecture, but they're fairly reasonable and easy to work within. But it also puts into the Teststand does all the flow control looping and pass-fail determination that we were talking about a little bit earlier, which means all my LabVIEW code does is just make the measurements. I don't care about any analysis or UI work or state machine stuff or timing of different parts of the test process. That's all in the Teststand side of stuff. So from that, yeah. Manage your project cross testing, yeah. So it really comes down to you have to really think in two spaces. I have my Teststand code that is doing my sequencing, and I have my LabVIEW code that's doing my measurements. And trying to think about it all as one entity and doing your project across your Teststand code and your LabVIEW code is very difficult. But if you can abstract out of, I'm just focusing on the LabVIEW code, I have a good model of what that VI has to do and trust that my sequencing and Teststand will behave itself, things become very manageable. And it's a great way to split off teams if you can define that juncture well of, I'll get you these LabVIEW VIs that make the measurements in 2 weeks. You start working on sequencing and doing the idea of I'm doing a bandwidth test and a noise test and a DC test, and I'll have you those test modules in 2 weeks and you can plug them in and go. And a good way to split up a team of people to improve your speed of time to market. So that's the end of what I got. Questions? If you have other questions, thoughts, let me know. Timing wise, we've got a couple more minutes.
We just wrapped up in that room too, though, so if there's
Okay, so if
Nothing
you
else
ask
we
questions, you're standing between us and getting free stuff, but.
From the beginning, you state that the NI will do a good job on the measurement, all those stuff like that. It says a sequence supplied by the NI or the test and sequence.
Right, so NI has an out-of-the-box standard process model. They actually have 3 or 4 or 5 default standard process models as a template to start from, depending on your general process that you're looking at. The out-of-the-box stuff is very simplified towards the idea of, I'm gonna do a computer motherboard.
I see. You just add on those.
Right, and you can take those out-of-the-box process models and modify them and add all this other complication onto it to get there. Unfortunately, I'm not aware of them providing a fancy, complicated process model that really adds a lot of this on as a reference design yet.
I thought they would buy all those.
No, no. Question? All right, thank you, everybody. It looks like it's a, we'll cross back to the main room and meet up there for closing ceremony.
Yep.